Okay, well, welcome everyone on this tutorial on how to install or configure a PXE server using 64-bit UEFI. The reason I'm making this tutorial is because I really couldn't find anything like it on YouTube. All I could see is basically pretty outdated or basically not usable nowadays. And you know, for the people that want to do it in Linux, here's a tutorial. Okay, so let's begin with it. I'm not going to explain how PXE works. There's pretty good tutorials for that or videos on that. So I'm just gonna go through with it. So let's log into my Raspberry Pi, which is going to be the PXE server. Okay, let's make the letters a bit bigger. Okay, so first things first, we are going to need a few packages. Firstly, a DHCP server and a TFTP server for the most basic configuration, but we also need some common files from syslinux for this. So let's install that first. So the packages are syslinux common, and then syslinux.cfg for the EFI files, since it's an UEFI PXE server. Then we will need a DHCP server, and then a TFTP server. I've seen other tutorials online that use, oh, excuse me, the server, so the daemon. I've seen other tutorials that use DNS mask as a combination between DHCP server and TFTP server, but I wanted to use these two packages because I feel like they represent what they are meant to do. So you can see the service failed already because basically it's unconfigured. So we'll do that later, but for now let's just stop the service. I see DHCP server. There you go. So to start with, let's go to the directory where we will install all our configuration files and everything. So let's make it. Let's call it TFTP boot. So in this directory, we'll need a few files from the syslinux libraries that we just installed. So mainly, we will need some files from user lib syslinux, and then its modules, EFI, and since this is 64-bit, then 64. So here we have a few files. So we're going to copy. We need ldlinux.e64. What else? We need, actually, let's do it like this, where we can specify different amount of files at once. We need ldlinux, then we need libutil. Oh, it doesn't autocomplete. Great. We need libutil, we need menu.c32. So from this folder, we only need 3 files: ldlinux, libutil, and menu. By the names, I'm not sure exactly what they do, but by the names, this is the menu we boot into. This is probably some utilities the menu needs, and this is what loads the kernels. So we're done here, but then we need one more file from not lowercase syslinux, rather capital letters syslinux EFI. So in our case, again, EFI 64, and then this file. So we copy that into, oh, there you go. So right now we have these files here. We also need a folder that will store our default configuration, so the entries that will appear in our boot menu. And this folder needs to be called pxelinux.cfg. it has to be called like this. And you need super user. So now that we have this, let's very quickly configure our TFTP server, and then we will move onto DHCP. So to configure our TFTP server, it's very easy. You edit etc default TFTP HPA, and here you specify that the root directory for the server is not this, but rather TFTP boot. Very simple. And now that I see this, it's probably a good idea now to remind people that you should probably allow that on the firewall. So you need UDP port 69. I already have it enabled, so there's nothing to allow anymore, but you probably should. Okay, so now that that's configured, we probably can enable the service. So systemctl start tftpd HPA, and that's it, it's running. Okay, the next step, and I would assume it's the main step, is to configure the DHCP server. So if you have like a real firewall or a real router, you probably have the settings for it. So this is just a Google image of pfSense that has options to specify our boot files per se, and it also specifies which is the TFTP server. But in our case, I have a 10 euro router that doesn't support any of these options, so we need to configure our own DHCP server. So let's edit that. To edit it, we need to go first to the, to etc DHCP and DHCPD. Oh Lord. Here we go. So this is the default file, and basically let's just remove some options that we will use later on. So I don't need that since it's going to be later, and we can put something like this. So to specify a subnet, first we type subnet, and then the actual subnet we want. In my case, it's this. Then we need to specify the net mask, which is a /24 in my case. And then here we have some normal options like the range of IP addresses we want to lease. And the maximum. Oi. That's more than enough. And remember, finish these lines with a semicolon. So then we will specify where the router is. I only have one. And it's located at 01. Then we can specify the default lease time. To about 1 hour in my case, and the maximum lease time to about a whole day. So these are some basic configurations. We should probably also configure the DNS servers that are being sent from DHCP. I like 1 dot, so that's what I will use. And we should probably set that this server is now the official DHCP server, since I disabled my other one. So we should probably set the DHCP server as authoritative. So here come the actual important options. Firstly, we need to specify where the TFTP server is. So in our case, this is going to be the Raspberry Pi, which has a statically assigned IP address. I strongly suggest that you also do that. but here we need to specify the option. So this is next server, and then the IP address of it. So in my case, the Raspberry Pi, which has an IP address of 0105. And also the file that needs to be pointed at, basically, if that makes any sense. So option boot file name, in our case it's syslinux.EFI. Okay, so basically this means that PXE will receive this IP address as the IP address of the TFTP server, and it will try to fetch this file from the root directory of the TFTP server. This looks good, and if it doesn't, the service will complain. So let's write that, let's exit that, and we need one last thing before being able to start the DHCP service. So first we need to know our interfaces. In our case, this is the network interface that is connected to the wire. So we need to edit etc defaults and then ISC DHCP server. And the reason we need to edit this file is because we need to, oh, whoa, the quotes, they died. We need to specify which interface should be giving out or should be listening for DHCP requests, basically. So that's done. Okay, before continuing, I'm actually going to re-edit the file again. Not that one, but this one, so I can add some static entries for my network. So for instance, this is just some copy-paste configuration from another file. I'm specifying that my desktop, which has a MAC address of this, is going to have the statically assigned IP address of 103, and this Raspberry Pi is going to have the statically IP address assigned of 105, even though I strongly suggest that you set a static IP address for the interface either in /etc/network/interfaces or whatever your network manager you're using, basically. Oh yeah, we probably should write that. Okay, so we're almost set. Let's actually start the DHCP service. Actually, it's ISC, DHCP. These have terrible names. A server. Oh, wow, it didn't complain. That's... wow, okay. Good. So, right now, we have everything almost set up. We're missing just two small things. So, in my home directory, I've pre-downloaded a Debian ISO. It's important that the Debian ISO, or whichever ISO you're downloading, is ready for net booting. And this is because it needs to have all of the necessary files inside the Linux kernel and the initrd for it to be able to boot. So in my case, I downloaded this net installer. So what I'm going to do is create a folder inside our TFTP boot called Debian, and copy all the contents of this image inside the Debian folder. So let's mount it first into /mnt, for instance. Yeah, that's fine. And then we copy mnt, everything in mnt, we copy it into TFTP, into Debian. So we know that the Debian distribution will be here, or at least the net installer. Okay, it's finished. Wow, that was slow. Well, now that it's finished, we can create the configuration file that will be pulled from the network to load the menu, basically. So let's go on to pxelinux folder, and the file needs to be called default. there are other options, so you can create other files that will be basically matched based on MAC address, but the default file is basically the catch file that will capture them all, basically the last file that it asks for. So default, there you go. So what do we put in this file? We basically put the entries for the menu. There is a very good page on the syslinux wiki on all the different bells and whistles you can add to this file, but I'll make a very simple one for the tutorial. So basically we need to specify which user interface we are using. So in our case, we're going to be using menu C32 that we pulled before. And this needs to be in the root of the TFTP server as shown before, which in our case it is. Then we use a label. And this just is to give it a name, basically. In our case, it's like Debian net boot. And then we need a menu label. And again, something like this. So then now we need to specify where the kernel of our image is located. And if we see here, it's in a TFTP boot, right? But we copied it into the Debian folder. Inside this folder, there aren't really any kernels or anything, but in reality, they're hidden in this folder. And these are the actual files that we need. Technically, we don't need any of these files for this installation. So if we go to install.amd, here's where the files that we need are. We need initrd.gz and vmlinux. So here we need to specify where these files are. So the kernel, which is vmlinux, is actually located at Debian, and this is a relative path to the root of the TFTP server. So in our case, it's in Debian install AMD, and then the kernel vmlinux. Whoops. We don't need any more bells and whistles for this purpose, but we do need to also specify where the initrd is. So for this, we can use append initrd equals, and then again the path of it. So in our case, it's Debian, always respected for the TFTP root directory, install AMD, and then initrd.gz. So now we can add some text, some help text. This is completely optional, but you can use it for yourself. So let's put something like this, and then we can finish it off with end text. Okay, so that's actually it. We have our default file. We have everything that we need to boot from PXE. So to test this, I have a virtual machine that we can run. Let's see if this opens. Oh, not this one. Excuse me. So here we go. It's trying to boot over PXE. It managed to find something. Oh. Received TFTP error. Oh no, something went wrong. Let's see. Okay, so after some quick troubleshooting, I just discovered that even though I had already started a TFTP server, I hadn't restarted, so the new configuration with the new directory was not in effect. So that was the issue. So let's actually restart the service. HPA, okay. Let's hope that works, or I'll be very sad. Okay, MVP file downloaded successfully. There you go. So that's the Debian minimal install. If we press enter, it starts pulling the files from the TFTP server. That's okay. and since the initRD is a bit bigger, it's going to take a bit longer, but I'll probably make a tutorial on how to do this with HTTP, so you can get really big initRD files. And there you go. It managed to successfully boot into the Debian installer. Alright, thank you very much for watching the video, and yeah, stay tuned for the newer ones with HTTP booting.